Hello, Roman from Avivisions here, bringing you this week's Photography Fact of the Week. Now, this week's topic will be film, and I'll be going over what film is actually made of, and how it works to capture the light when you expose a photograph. So I've taken the liberty of pre-drawing everything out here because I have never done one of these videos before. Usually, this is Connor's domain, but anyway, let me just scroll through here and show you a brief preview of what it is we're going to be going over with. Alright, anyway, back to the beginning. So, as I said before, I'm going to tell you what film is actually made of, and I've shown here the different layers that are typically found on a layer of film. The bottom layer, the plastic layer that you actually hold and see, that goes and rolls into your camera, is the plastic layer known as the celluloid layer. And this is just sort of the backbone of the film where everything is placed on top of it. And if you're taking a picture, the light would be going in from this direction, being recorded on this side. So this is definitely the back side of the film. The next layer from the celluloid layer is the gelatin layer. This gelatin layer is really just there to hold the silver halide crystals to the celluloid layer. The silver halide crystals are in white, and you can see this white layer right here. Interestingly enough, gelatin is a byproduct of, it's actually an animal product. It's not a byproduct of animals, it's an animal product. So the gelatin that you have in your film has a lot more in common with your hamburger than you might expect, as well as the jello that you eat. It just sort of gives it that consistency. So this gelatin layer is actually perfect for holding silver halide crystals and a multitude of other coatings to the celluloid layer. So the silver halide crystals are what actually record the light. So the silver halide crystal is actually what's recording the energy, the light energy, or the photons. And silver halide crystals is just really a general name for a whole series of silver halogen-based crystals. And you'll see here I have written out the different halogens. You may or may not remember them from high school chemistry, but we have bromine, iodine, fluorine, and chlorine. Now, bromine and iodine are the ones that are most commonly used for film. So when I say silver halide crystals, that's really what I mean for this whole entire layer. Different types of crystals record different light frequencies, and they can also vary in sensitivity. So if you buy ISO 1600 film and ISO 100 film, they're probably going to have a different variation in silver halide crystals. On top of the silver halide crystals, you have these coatings. These coatings are really just there to block out certain spectrums of light, most specifically infrared and ultraviolet. So those coatings aren't really important. You should just know that they're there on your film to help block out certain spectrums of the light. Moving on down now, so this is sort of what happens when you expose a photograph. You have photons, or in other words light, travel and hit the silver halide crystals. But as I said before, if you have no coatings, you're actually recording the visible spectrum, the infrared and ultraviolet spectrums as well. So what the manufacturers of the film did was they added those coatings in front here. Let's just pretend these are the coatings. And that blocks out most of the infrared and ultraviolet light. Moving on down now. This is just sort of a reiteration of what I just said. It actually helps you to see a little bit better. Here I just drew one coating, but really there are lots and lots of these. And it's actually really cool to think about how thick this ends up being. It's 1/1000th of an inch. So it's still really, really small. And you could just see that by holding film in your hand. So all this is really, really microscopic. It's almost invisible to the naked eye, actually. You could barely tell if there's anything on the film. So here we get to the question of why is it that, let me move some of this over, it looks like it's going to get cropped off the screen. Why is it that film records more detail than digital? Well, in the previous week's episode of the Photography Fact of the Week, we saw how digital sensors record light and how they have that certain level of uncertainty and the heat that radiates off of the little pixels of the sensor. Well, in film, when you have a photon that hits the film, the silver halide crystals more specifically, it actually causes a chemical reaction, and the photon becomes a part of the crystal. So if you look at this little sensor array that I've drawn here, you can see that on the digital sensor you have each individual pixels that are recording information, and they have that certain level of uncertainty, and the heat radiates from the sides, as shown right here. And that causes the level of uncertainty in the pixels next to it and whatnot. But when you have film, it just records a single photon, and that photon becomes a permanent part of the silver halide crystal. I'm not going to go over the specific reaction that takes place. It's not too complicated, but basically the photon gets captured in the silver halide crystal, and it becomes part of the silver halide crystal. And then when you go and expose, or when you go into the dark room and then you do chemical reactions with your film there, you're basically just bringing out this information that you've stored when you exposed your photograph. And this gets the whole dynamic range of film. Basically, when you think of film, you could think of the dynamic range being 0 photons recorded to an X number of protons recorded, and that's your dynamic range. And you have a dynamic range for digital too, and it might be from 0 light to a specific number somewhere along the line here. But the beauty of film is really that because of your ability to change the sensitivity of the silver halide crystals, you actually have a higher dynamic range. Now before I end this video, I want to just quickly again go over how it is that you can actually have different sensitivities in film. So basically, let's say you buy ISO 1600 film and ISO 100 film. ISO 100 film will be less sensitive to light, right? So basically all that means is, let's say you have your silver halide layer right here. This is the celluloid. You have the light coming in from this side. It basically means that certain photons will not react when they hit the silver halide layer, whereas with ISO 1600 film, they will react. So basically, it's just a matter of, will the photons react with the silver halide layer or not? That's all that's really happening when you have different sensitivities in film. One last note is, the way the sensitivities differ between film roll to film roll is not actually a difference on which type of halogens they use, it's a difference in crystal size. So 1600 sensitivity might mean that the crystals are a lot larger, and ISO 100 means that they're a lot smaller. Larger crystals also mean that you'll have a bit of that grainy texture, simply because of the way the photons hit and react with larger crystals. Okay. Alright, I hope you enjoyed this video. I know I didn't cover everything. I wanted to keep it nice and short, but I hope it was a nice overview, and yep, that's it. Have a nice day.